Hello. In our comprehensive tutorial today, we'll walk you through the step-by-step process of networking 32 individual LS inverters. We will utilize the industry-standard Modbus RTU communication protocol to establish this connection and demonstrate how to seamlessly integrate everything using an LS Compact PLC as your primary controller for the entire system. In this project configuration, our Programmable Logic Controller, or PLC, functions as the primary client in the network, while the inverters we have integrated into the system serve as the dedicated servers, responding to requests and commands from the controller to ensure precise operational control. For the specific requirements of this project, we have selected the LSG 100 series inverters to manage our motor operations. To ensure precise communication and control, we have carefully assigned a unique station number to every single one of these inverter units. By leveraging the robust Modbus RTU network architecture, we establish a reliable link that allows us to dynamically adjust and change the operating frequency of each individual inverter directly through our Programmable Logic Controller, or PLC, providing us with seamless and centralized system management. For this specific project, the PLC model we decided to use is the XECDN 32 Edge series. To establish communication, we utilized its built-in RS-485 serial port. This means the interface has one positive 485 terminal and one negative terminal, which we carefully connected directly to the corresponding 485 communication ports on each of these inverters. We set the station number for the first inverter to 1. For this final row, we are going to set the station to 8. Moving forward, the next one, which represents the very first station in the following row, will be station 9. We will continue this pattern sequentially, counting up from station 9 all the way through to station 16. We will keep following this exact same process for each subsequent row, eventually reaching station 17, which leads us all the way to our very last inverter, which is officially designated as station 32. This means that the specific station address for this inverter is set to 32. To manage the entire system effectively, we've systematically assigned unique station addresses ranging from 1 all the way up to 32 to each of these individual inverters. By leveraging the capabilities of the Modbus RTU communication network, we gain the ability to precisely monitor and dynamically adjust the operating frequency for every single one of these inverters independently, giving us full control over the system's performance. The key point here is that the response time for these specific inverters, and I am talking specifically about the LSG 100 model, is actually configured to 5 milliseconds right out of the box by default. Because of this, there is absolutely no need for us to go in and manually adjust or change that response time setting. In our particular application, that 5 millisecond window is perfectly adequate, and it works just fine for all of our operational purposes without requiring any further modification on our end. So, for example, let's go ahead and change the specific value for this inverter, which currently has a station address of 32. I'll set its frequency value to 50 Hz, and if I confirm this change, you'll see that the inverter's frequency updates very quickly, and it is now successfully set to 50 Hz. This demonstrates how easily we can adjust these parameters in real time to meet our operational requirements. Next, we are going to take a much closer look and get significantly more familiar with the specific programming logic that we implemented within the XG5000 software environment. So to give you a better overview, this is the complete program that we carefully wrote for this particular project inside the XG5000 software, which we will now walk through step by step. As we explained in previous tutorials, the first step is to navigate into the CNET section. From there, you need to configure both the baud rate and the station number for channel 2. Please ensure these values are set correctly for proper communication. We are going to set the baud rate to 9600. And a very important point to keep in mind is that the baud rate for all of these LS inverters must also be configured to match, specifically set to 9600 as well. Since our PLC is currently acting as a client, we first need to set its station number to 0. Then, moving on to channel 2, which specifically corresponds to the 485 Rupes communication port, we need to ensure that we set it to use P2P mode to complete the setup. And just as we explained in our previous tutorials, if you go ahead and right-click right here, then select Add Item, and finally choose P2P Communication, you will see that we have three distinct sections available here. We have a P2P channel, where we selected the Modbus RTU client for our second channel. Now for our P2P block, which is this table here, we need to go ahead and fill it out. Well, if you take a close look at this table of ours, you'll see it actually contains 32 rows in total. That means we are counting from row number 0 all the way up to row number 31, which, when you add them all up, totals 32 rows for our dataset. We assign each of these individual rows to a specific inverter, and as I mentioned previously, for our inverters, we carefully choose from station number 1 all the way up to station number 32. Now, this particular section of the table is dedicated specifically to the station number. So, as we've discussed, we set each row to correspond directly to one unique station number, ensuring that every single row is properly mapped and accounted for in our system. Well, as we covered in the previous tutorials, we successfully learned exactly how to fill out this specific table. If you find that you need a quick refresher, please feel free to refer back to our previous tutorials at any time for more guidance. What is really important for us to focus on right now is the fact that in the very last section of this table, we have both a designated read area and a save area. It is quite essential to note these two distinct sections. The read area is essentially that specific memory address coming from our PLC where we are supposed to input the frequency data we want to track. Moving on to the save area, this is where we need to be a bit more precise. We are required to input the specific address of 40,004 into that field to ensure the system correctly saves our configuration settings for the operation. Because the specific address related to the frequency parameter in the LSG100 inverter is 5, we need to subtract 1 from that value and then input the number 4 here. This calculation effectively points us to the correct Modbus register, which is address 40,004. This ensures that the communication is properly aligned with the drive's internal mapping. So for each of these individual inverters, we need to input the address of 40,004 into the save area section, which is a crucial step to ensure that every single unit is configured properly for the system. The only thing that is actually different in this table for each of these individual rows is this specific station number column and this read area section. To walk you through it, for our very first station number, we went ahead and chose MW1. And then for our second station number, we selected MW2. And if you follow that same pattern all the way down to the 32nd station number, you will see that we ultimately chose MW32 for that final entry. Well, after we finish filling out this table, we can then go ahead and enter the XG5000 software environment. In this configuration, we have utilized a total of 32 move instructions. For each of these, we assigned input 1 through input 32 to the corresponding inputs of the blocks. Furthermore, we have configured the outputs of these move instructions to map sequentially from MW1 all the way through to MW32, completing our data transfer setup. The only thing is that for the specific input requirements of these particular move operations, we really need to make sure to select the data type as an integer. It is important to remember that this means the data we choose must specifically be of the whole number integer type to function correctly. Thank you very much for your attention.